Welcome. Today we are going to discuss another topic from the domain of philosophy of AI. Our question: how do brain-computer interfaces contribute to cognitive enhancement? And what philosophical and ethical issues arise from this? Brain-computer interfaces, BCIs, are no longer limited to medical applications, such as restoring motor control or communication in paralyzed patients. Increasingly, they are being explored as tools for cognitive enhancement, that is, for augmenting memory, attention, perception, and decision making beyond the natural human range. Cognitive enhancement through BCIs aims not merely to repair deficits, but to amplify normal cognition, thereby extending the limits of human intelligence through direct integration with artificial systems. The first element in this context, which I would like to mention, is about cognitive enhancement through BCIs and AI. AI-driven BCIs enhance cognition primarily through neural feedback, memory assistance, and decision support systems. For example, neuroprosthetic devices can stimulate specific brain regions to improve working memory or modulate neural oscillations to sustain attention. Machine learning algorithms process neural signals in real time, detecting cognitive states such as fatigue or confusion, and adjusting stimuli or feedback accordingly. This capacity to close the loop between mind and machine effectively allows the AI systems to co-regulate human cognition. In this sense, BCIs embody what philosophers of technology call co-agency, a shared locus of control between human and artificial systems. The cognitive process becomes distributed across neural and digital substrates. Philosophically, this recalls the functionalism of Hilary Putnam and Jerry Fodor, according to which mental states are defined not by their physical composition, but by their causal roles in a system. If so, cognitive enhancement via BCIs might represent not a departure from human cognition, but its functional continuation in a new medium. And our second element is about philosophical challenges. I mean here selfhood, authenticity, and the nature of thought. While BCIs promise to enhance intelligence, they also raise profound philosophical questions about the authenticity of cognition and the identity of the self. If one's memory or reasoning is partly supported by an AI algorithm, is the resulting knowledge genuine one's own? This echoes classical concern in the philosophy of mind about personal identity and mental ownership. The notion of a cyborg self, a being whose mind is partly biological and partly artificial, disrupts traditional dualism between mind and matter, natural and artificial, inner and outer. From an epistemological perspective, BCIs blur the line between knowledge and information. A person may access vast computational resources via a neural interface, but does such access constitute understanding? Hubert Dreyfus and later John Searle argued that AI systems, however efficient, lack the intentionality, the aboutness of human thought. Extending this critique, one might say that cognitive enhancement risks reducing thinking to computation, ignoring the phenomenological and embodied dimensions of intelligence. Okay, what about ethical issues? Autonomy, privacy, and cognitive liberty. The ethical implications of BCIs are equally significant because BCIs directly interact with neural data. They pose unprecedented challenges to mental privacy and autonomy. Neural activity, once decoded by AI, could reveal intentions, emotions, or preferences, raising the specter of neural surveillance. Moreover, as BCIs become more sophisticated, the boundary between voluntary and algorithmically influenced decisions may erode, challenging the traditional notion of free will. Philosophers such as Thomas Metzinger have warned that technological extensions of the mind might unintentionally manipulate self models, altering one's experience of agency. Another ethical concern is social justice. If cognitive enhancement technologies are accessible only to the wealthy of technologically privileged, they could exacerbate existing inequalities, creating a cognitive elite. This possibility echoes the transhumanist aspiration to transcend biological limits, but it also recalls the bioconservative critique that such enhancements threaten human dignity and equality. And our last subtopic for today's discussion is about the future of human AI cognition. Philosophically, BCIs force us to reconsider what it means to enhance cognition. Enhancement is not merely quantitative, more memory, faster reasoning, but qualitative, changing how we experience thought, attention, and self awareness. The ultimate question is whether BCIs will lead to a more integrated, reflective intelligence or to a fragmented hybrid mind dominated by algorithmic feedback loops. As AI systems evolve toward increasing autonomy, the relationship between cognition and artificial systems may evolve from assistance to codependence, a transformation that redefines the boundaries of intelligence itself. In sum, BCIs represent both a triumph of human ingenuity and a philosophical frontier. They challenge our understanding of mind, freedom of identity, urging us to construct a new ethical and epistemological framework for life in an age of neurotechnological co-evolution. Thank you for watching. That's all for today's discussion. See you later.